Okay, let's get started. So today's agenda is first at a high level. We will be looking at the impacts of COVID, and then we're going to look at some federal and state government level policy responses during this recession. Specifically, we'll be looking at some federal and state programs and also some market-based solutions. And after that, we're going to discuss our REMI E3 Plus model and the modeling methodology. And after this brief overview, Brenda is going to give you a demonstration in REMI E3 Plus to show you how to actually model different scenarios using the software. Okay, now let's jump into the impacts of COVID, especially the impacts on climate change. So COVID can affect the environment and climate change in both positive and negative ways. So on the positive side, the world now has lower greenhouse gas emissions because now everyone works from home and commute demand is significantly less. In addition, we also see more biking and walking in dense areas in all these metropolitan areas. And I think the reason is partly because it's a good leisure activity for people who work from home and sit all day. But also there is some safety concerns. Biking and walking is presumably safer than taking public transportations. And lastly, we have the policy where the production tax credit for renewable energy projects is extended for 1 year. So this is presumably providing additional support for these projects. So these are the positive side of the impacts of COVID, but we also have some negative aspects. So for example, because of the COVID disruption, we now have delayed international and domestic political processes to work on the environmental and energy issues. And because COVID brings in some economic recessions, so now like state and also federal government are facing shortages of funding. They have very tight budget, and therefore it's less likely for them to spend money for resilience and renewable energy project, because obviously these are not their first priority at this moment. And lastly, we also observe more single-use plastic. For example, I noticed myself that previously you can use your own bags in grocery stores, but now because of the safety concerns, the stores basically encourage you to use the plastic bags. And also we have to wear gloves, wear masks. So these definitely have health benefits, but also on the other hand has some waste, and it's not good for our environment. So let's look at some examples of the COVID impacts, which we just briefly discussed. So this graph shows the projected change in primary energy demand by fuel category in year 2020 relative to year 2019. So as you can see from this graph, the overall energy demand in the US is down by 6% this year, especially for coal and oil. And renewable energy usage, in contrast, has increased by about 1%. However, these changes are fairly small, and it's only for a short amount of time period. So it's not really clear to us whether these changes will have significant impacts on the trajectory of climate changes. Another example of the COVID impact is now we walk and bike more. We have some sources which shows that the sales of children's and adult leisure bicycles have increased by 56% and 121% since March. And not just like bike, but also all outdoor activities basically increased a lot. So it's very hard to buy outdoorsy equipments. And bike shops globally are experiencing some shortages, and it's partly because increasing demand, but also the slowdown of global trade caused the supply chain to be disrupted, and therefore the supply side is also affected significantly. And lastly, we have University of New Orleans study that shows there is increase in working child usage on campus. And I believe it's not just on campus, but I see a lot of people just like walking around in my neighborhood every day. So it seems like working child is also in high demand these days. And lastly, we're going to discuss the fiscal shortfalls. So obviously, COVID has hit state, local, and federal government funding significantly. And as they all face revenue shortfalls and expenditure increases, because of increased unemployment claims and also decreasing gas tax revenue, it's very difficult for them to spend extra dollars on energy and environmental issues because it's not the first priority in their mind. Okay, so after looking into the COVID impact on environment and energy, let's take a look at the federal and state policy responses. So in this webinar, we will discuss the Green New Deal, and we'll also discuss some market-based solutions such as carbon taxes. And if time permits, I'm also going to briefly touch on the electric vehicle use and its impact. So what is the Green New Deal? So Green New Deal is proposed by US Representative Ocasio-Cortez and also Senator Markey. It's a very ambitious plan. It describes environmental and economic goals to be achieved in 10 years, which is very multidimensional. It has many sub-goals, sub-plans. So for example, the Green New Deal proposes that we meet 100% of power demand in the US through renewable and zero emission sources. Also promotes energy efficiency, clean manufacturing. It also has resiliency to mitigate the impact of natural disasters and also to upgrade infrastructures. So the Green New Deal is proposed a while ago, and even as of today, the Democratic Party nominee Joe Biden has incorporated several aspects of the plan into his platform. So of course, energy and environmental issues will be a big part in his plan for the presidential election. So what's the political context of this Green New Deal? So I guess there are several layers of backgrounds. So first is, we see increased public concern about climate change.
It seems, hi, I'm Brandon. It seems like at least I lost sound from Natalie.
Seems like we lost Natalie, yes, Brandon. It seems like we lost Natalie for a second here. So
Okay.
we'll wait for a minute or so before she logs back on. She might have technical issues.
Yeah.
And she is connecting. Sorry about this technical difficulty, everybody. How about this, Brandon? Would you mind actually, as we're going forward on this, looks like we've not lost Natalie. She's coming back on. So just in the meantime, how about to present?
Sorry guys, can you hear me again?
Yes, Natalie.
Oh, sorry.
It's
Yeah,
working
there's
now.
some
Thank you.
internet disruption here. So I guess what's the plan for now, Billy? Should I take over? Hello?
Yeah, Natalie, go ahead.
Oh, okay. Yeah, so I guess before my network connection is lost, I was just talking about the political context of the Green New Deal. So I guess I'll start with this slide. So I guess the background of the Green New Deal is that we observe increased public concern about the climate change. And this concern is particularly pronounced among younger generation of adults. For example, for people who are aged 18 years old to 34 years old, 70% of them are worried about the negative climate change. And even for people who are relatively older, for example, people from age 35 to age 44, more than half of them are still worried about climate change. And also among general population, there is a dissatisfaction with perceived Republican denial of a problem of the problem, and overall, like people are disappointed that the status quo politics of elected officials, including the Democratic Party, fails to resolve the problem. For example, during President Obama's first term, U.S. House passed cap and trade bill, but it's never came to a vote in the Senate. So, linkages with a range of economic and social challenges, such as income inequality, marginalized community, are also part of the negative aspect of the climate change, which was not addressed properly. Okay, and why addressing the climate change issue or the energy and environmental issue very important for the state and local government? So climate change matters to all states, whether they are blue or red. Specifically because, for example, we need to look at the resilience concerns such as the hurricane, the wildfire, and the coastal and inland floodings. And for these natural disasters, state and local governments are responsible for finding solutions to these problems. And if the government keep avoid making solutions or regulations, people will feel disappointed and there might be some political backlash. For some very natural resources dependent states, I think it's ideal for them to further diversify their economy, since the oil and gas prices are very volatile and will be depleted over time. So a good example for the COVID crisis is that, because of the shutdown, we have less air travel, less road travel. So the oil price and gas price basically drop significantly, which is a big hit to states that depend largely on the oil and gas prices and these companies. And even for coastal states, investments in infrastructure is very important, as they reduce the transportation cost when they export energies, when they export oil and gas to foreign countries. Okay, so why do we need economic? So basically, the Green New Deal represents very aspirational goals. It's, as I said, very comprehensive, very multi-dimensional. However, implementation of even a small aspect requires detailed understanding of the engineering of the project and also the economic, environmental, and financial issues underlying the implementation. So we propose that REMI has extensive knowledge involved in, and we are involved in national, state, and local evaluations of the economic effects of environmental and social policies. So we can be a good resources here if we want to look into the impacts of the implementation of policies such as the Green New Deal. Okay, so after an overview of the COVID impact, I'm going to quickly discuss some market-based solutions. So for example, one market-based solutions will be a carbon tax. So a carbon tax is an efficient means for reflecting the cost of carbon in economic decision-making. So for example, in the past, there is some discussions that maybe the legislation will require energy companies to pay, for example, $15 per ton of carbon emitted from producing products. And this and the fee will be rising by $10 each subsequent year. So the government will collect revenue from this carbon tax, and they will return basically the profit to the taxpayers. So this is a way to encourage companies to try using renewable energies or green energies, and to boost the economy from that. However, the carbon tax is also very controversial because some progressive people believe that this is insufficient, but conservative people will believe that it's going to be a burden for the company, and therefore it's going to harm the economy as a whole. So I think this is some report from our client. Use the REMI model to examine a hypothetical carbon tax initiative. So basically, in this scenario, the carbon tax is introduced in year 2018, and therefore, and after that, they look at the impact of the carbon tax on employment, sales output, GDP, and real disposable personal income, in short, RDPI. So as you can see, as many people has worried about, introducing the carbon tax will decrease employment, sales output, GDP, and personal income in the short run, because obviously it's a burden for the economy, and many gas and oil company, I guess, will have to lay off people, and therefore decreasing employment. However, if you look into maybe like 8 or 10 years later, it brings positive impact to the economy. As you can see, from year 2026 and onward, we see increasing employment, sales output, GDP, and RDPI, which suggests that introducing a carbon tax will have benefits in the long run, but the cost will be the short-run economic disruption. So here are some direct impact of this hypothetical carbon tax. Here we are looking into the reduction of emission. Specifically, we break the results into non-power sectors and power sectors. So of course, the power sector is having a very tremendous decrease from the emission, just because the carbon tax directly targets to them. But we also see a significant decrease in the non-power sectors as they gradually switch from traditional energies to renewable and cleaner energies. So I'm going to skip discussing the electric and hybrid vehicles. So the slide will be posted online, and take a look. Feel free to take a look if you are interested in this issue. Okay, so how can REMI help in these energy and environmental issue? So REMI is the best commercially available tool for economic analysis. we have rigorous peer reviews, research, and software development to generate our forecast and economic output. So REMI's mission is to provide data-driven predictive policy analysis in order to assist public policymakers with making informed and evidence-based decisions to improve the economic outcome of the area. We provide not only an economic breakdown, but our models include a fully fledged demographic profiles to analyze the specific demographic breakdowns of the region. And not to mention, we also provide unlimited client support and training on our models so that your organization uses our model accurately and to the fullest. Okay, specifically, we have the E3+ model, which is our model that's specific on the environmental and energy issues. So using the E3 model, we have investigated into various local energy initiatives and worked with lots of clients across the country. So some of the previous analysis include, for example, for the New Hampshire, we look at their energy reliability project. For New York City, we looked at their energy efficiency program. And for California, we looked into the impact of CAFE emission standards. So I wanted to note here that because REMI is an economic analysis company, so we do not really take any stand on whether we are pro-green energy or we are against it. Our goal is to provide data-driven analysis for the economy, for the energy, and for the environment. And going back to the topic of today's webinar, we're interested in new information after COVID, and we're interested in looking at the new general equilibrium, what's going to happen after the COVID era. So specifically in our model, the energy, environment, and economic aspects are linked in a way that, for example, if there is any economic impact, what's going to change the energy price? And for example, if the energy price changes, what will be the economic impact? So you see these two things are actually like in both ways. And also if there is, for example, long-term employment changes, what's going to happen to environmental regulations? And for example, how when people switch from old energy sources to new green energy, what's the impact to the environment? So our E3+ model has various aspects that are very unique. For example, we have the translator variables for electrical, solar, wind, and nuclear power plant construction and operations and maintenance. We also have some specific modules such as the resilience module and emission module, which allows you to look at the energy consumption and the carbon dioxide emissions, as well as the natural disaster resilience. So I'm going to discuss some of the features briefly here, and Brandon will be discussing them in greater detail in the model demonstration. So for the translators in the E3+ model, the model can basically distribute spending on construction projects into 160 industries. And we base our studies and data from several sources, which include National Renewable Energy Laboratory and Energy Information Administration. We also have a special emission module, which focuses on the carbon emission. So the forecast results will include energy consumption and carbon dioxide emission. And lastly, we have this resiliency module in the E3+ model. So this basically provides some forecast of the resilience of the natural disasters. So it compares like a baseline disaster scenario to a resilience investment scenario and see what the improvement are there. So this is just a quickly overview of how you can use the E3+ model. So For example, you can have various inputs for the model, such as new renewable energy development with retirement of the coal plant, or you can model a direct energy cost changes. And the model is going to produce the output results or the forecast for you, which will include, for example, the change in the output in various industries. For example, after an increase in the energy cost, what's going to happen to factory outputs and what's going to happen to employment. And also we have this dynamic aspect of the model, which is, for example, when we increase the energy cost, it's going to decrease carbon emission. However, it's also going to increase because it's also going to increase carbon emissions for travel in service industries, because maybe now the economy is doing better and people demand more travel. So there's also the dynamic aspect of the model. Okay, so I think I covered everything, and now I will hand over to Brendan to give you a model demonstration, so you'll learn the model in greater detail.
Awesome. Natalie, would you mind making me presenter real quick so I can
yeah, sure.
share the screen? All right. All right. So hopefully everyone can see my screen. Leave a question if you're not able to. So I'm going to discuss the REMI E3 model briefly. I want to make sure we have enough time for questions. So two of the demonstrations that I put together, one addresses infrastructure investment specifically, and another addresses policy changes that could be made at the state or federal level. So the first one will be an onshore wind project, and I'll go into how it's done within the REMI model, what other options for infrastructure, energy infrastructure there are in the model, and discuss a little bit more about how it is input into the model. The second will be the carbon tax policy change. So this is going to evaluate a revenue neutral carbon tax at the state level. It's not taking into account specifically the arbitrage opportunities that would occur between different states and different countries if there was a carbon tax at the state level. But I'm showing the capability of the model to demonstrate those things. So we'll start with looking at infrastructure investments for the REMI model. If you're familiar with our PI Plus model, you have all of the same inputs from the variables and the topic scenarios, the same full variable list. For the E3 Plus model, we've added the environmental aspects module. So you're able to change specifically energy price and demand for electricity, natural gas, and some residuals. You're able to look at specific power plant constructions, and that's what I'm going to go into. You're able to also assess operation and maintenance costs, emission costs, and then we have a special module for implementing a carbon tax. And so I can show you how I go about this project for the onshore wind projects. So in this case, all of the coal-fired plants, offshore wind, natural gas, onshore wind, and so on and so forth, all of these have been incorporated into the model, incorporated into the national IO that's used to underpin the model. And so what does that mean? That means that we have the relationship between each of the construction projects. So say, $1 that's used to construct an onshore wind farm. How is that going to affect, what will be the dollar effect on, the construction industry and the retail industry and whatnot? And how does it affect energy prices, electricity, natural gas, coal? And then how does that then translate into, what is the energy usage, the energy demand over time? And so in this case, I went in to do an onshore wind construction project, which specifically looked at the region of Washington. It uses the IO table that we've input for this. And then what what I went and did was modeled a $220 million project. And so this translates, the way I got to that number was using the average cost per kilowatt hour, which is about $1,600 for a 137 megawatt plant that's supposed to power, say, 45,000, 50,000 homes. You'd be able to input these units here, so you can do nominal units, millions, add to the editor. And so in this case, the $220 million was spread over 4 years, I believe from 2021 to 2024. And then you can input that directly in the model. Yeah. So right here, $44 million over, actually it's 5 years. And so from there, I can show you what the output is. And so this is assuming an electric onshore wind facility. You could do this for a coal plant, for a nuclear plant, et cetera, and see how that affects the demand for energy at the residential, commercial, industrial level in the years that are the projects being produced, and also further down the line. And so you can see here in the three production years, 2021, 2022, 2023 to 2025, you see there's an uptick in the natural gas usage for commercial purposes, and then it falls off afterwards. This is a function, and you can see, of the construction project being used. So more energy, more energy is going to be needed in the capacity to build the project in this region, and then afterwards that'll fall down in electricity prices for commercial, as well as industrial and transportation will rise over time. And so not only can you see the energy consumption, you're able to also look at the economic impact. So you can see here the relative change in employment, output, personal income, price indices from a baseline model that's been adjusted for the COVID recession in 2020. And so you can see here, while the project's being pursued, you have total employment that's up by almost 100 jobs, GDP that's greater by 30 million almost each year, and then after that it'll peter off, just because you have a construction project and not accounting for maintenance. Will sort of revert back to the prior levels of GDP output, employment. And so you can see those things. You're also able to look at employment by industry, demographic, and trade. Since this is a one region model, we don't see where the effects are also being spread out to, but with the REMI model, if you do have, say this is Washington State, if you have Oregon and Idaho, maybe California, included in the model, you're able to see, if we build this project, are we going to be able to, where are some of the other benefits going? Will Oregon and Idaho also benefit from the fact that energy prices are, lower in Washington, or if they're higher, are, businesses going to leave and go to other states? That's all. You can see that in this model. So that's the onshore wind project. Now I'll go into the carbon tax. This one's a little bit more complicated, just because it requires a lot of different moving parts, especially because it's revenue neutral. And so you can go, what's nice about the carbon tax module in the E3 model is that we have pre-selected policy variables within the model that correspond to things that you would want to change for a carbon tax to be initiated. And so some of those are personal taxes, end-use energy costs, air quality, fossil fuels adjustments. The things that I looked at specifically, I'll go to inputs, was I looked at an increase in fuel costs. So because we're going to be taxing carbon, the cost of producing each ton is going to increase, and that'll then be passed down to consumers through the production process. That leads to the decrease in consumer spending as prices increase, especially for manufacturing, for energy generation. Those things will come into effect. And in this case, the way that I went about modeling the revenue neutral aspect is that the revenue generated from the tax is then dispersed as a dividend, quote unquote, to the people of Washington. So it'd be, say, like a tax write-off by X amount that can be then used by the public however they wish to spend it. There are other options. I mean, it's not just dispersing to people so that they can spend it. The revenues from a carbon tax can then be funneled into infrastructure projects. They can be funneled into renewable or energy projects, or supporting oil and gas industries in the region that may be struggling. And so that's a matter of policy, and we can go about modeling in several different ways. And so in this case, I modeled about a 6% carbon tax on industry in Washington. And so we'll see also the increase in fuel costs peters off after time as things become more efficient. So we can look at what the results look like. And so you can see I'll look at the economic summary. So you can see in the first year in 2020, there is experiencing dips in employment, dips in GDP. That's a factor of COVID happening, and there already being a national and regional level of dip, but also because that's when the fuel costs will be highest. As companies adjust, they're going to pass down a lot of their costs onto consumers. But over time, that effect becomes mitigated. As things become more efficient, say, businesses transition to renewables, or they transition to companies that are dispersing, or utilities that are dispersing electricity and energy more efficiently, that those costs will go down. And so fewer costs will be dispersed, passed down to consumers. Consumer spending will rebound, and consumers, now that they have the dividend, are able to spend more. So in this case, you see, in 2021 and down the line, you see an increase in employment, an increase in GDP that is pretty consistently increasing over time. That's because now people have more money to spend, and energy becomes less expensive as things become more efficient, and you can see those benefits out to 2060. And now this is assuming a flat carbon tax. These can be adjusted to be progressive, or depending upon, you could be in brackets. If you use X amount of tons of carbon per year, your tax is this rate. It can be marginal, is what I'm trying to say. And so all those things could be modeled within the REMI model to be able to account for a revenue neutral carbon tax.